Good afternoon, ladies and gentlemen. Welcome to the third FAIRWork seminar. We will talk about specification of use cases, requirements, and research approach. Next slide. The program for that is we will give you a core, an outlook about the FAIRWork's core idea. Then Christian will speak about the collection, design thinking process, collection of user requirements. Afterwards, we give you an overview of the relevant concept for research direction and implementation after such complex decision-making process. Silvia, Christopher, and Lucas give you some insights there. And finally, I will give you a step-by-step presentation of the initial architecture. Now I hand over to Christian, who will present you the first design thinking workshop.
Welcome, my name is Christian Muck. I have the honor to give you a short introduction about the goal of the FAIRWork project, so I keep it very short, just to give a context for this webinar, and then I will give you an introduction to the requirements approach that we used here in the project. So the goal of the FAIRWork project is to support complex decisions in organizations, for our case, mostly manufacturers, in the complex decisions, and which involve multiple stakeholders like humans and machines, how they can work together and how can we make fair and good decisions. To do this, we apply AI technology, which will orchestrated and mapped and directly configured for the specific decisions. This was the short introduction. Now I will go to the user requirements approach. So how do we define what we want to do and how we can map and decide these decisions and define decisions? So we have an design thinking based approach. So we have a very user focused approach with a physical design thinking workshop where the people can work together and really understand something, doing co-creation in these workshops. And then we use models as a central artifact to capture this knowledge of these workshops and communicate it to others, and then also enhance these models to capture really all the information knowledge that we need to support our decision process. The goal of this approach is exactly that we want to understand the decisions and their context. As they are complex decisions, we also need to understand the context. You can see down there that we have we focus here on the scenarios. So user scenarios, how are these decisions really made in the concrete scenarios of the user, and then we provide abstractions on different layers. Here the design scenario is the highest one, the most abstract one, where the focus is set on just understanding the decision itself for the humans mostly. Then after we have understood it, we create business processes out of it. So we enrich this information, make it more concrete and formalize it. And after that, we understand the decision and can map it to the technical components that we use to help this decision. To do this, we have a 5-step procedure. This layout of the procedure is the same as for the 3 abstraction layers. The first 2 steps are for the design scenario, then for the business process, and the last one is for the technical alignment. So we start here at the scenario design. What we want to do here is have, as already said, a design thinking workshop. So a physical workshop where people come together and discuss and understand this decision. To achieve this, we have a preparation step, which analyzes the domain. So we have to understand the domain where this decision is made. For our case, this was at the use case partners, Flex, where you see a picture above, and CRF, where you see a picture down. So first we talked about it, it gave us information, then we understood it. And this domain analysis also was the input for our workshop. So we prepared the concepts that we use in the workshop. As we use the scene to model tool, we have a physical workshop with physical modeling, which you can see on the picture. This is one picture of such a workshop where these physical objects are used to create and design the scenarios and understand it by the participants. And then we automatically transform this into a model to capture this knowledge and provide it to the other project partners. And then if we have these digital models, we can also improve it and refine it. So we have a representation that we can enhance. Just as a side note, we used SAP scenes for some of the symbols. So this is a well-known approach. Then we approach it and enhance it with this digital modeling. After we understood our scenarios, we created business processes. In the first step, a process landscape. So the important processes by our use case partners. So what are the important processes here? And then out of this landscape, we identified the important processes and specified them in concrete business processes using the BPNN notation here. And we also have not only the steps and the tasks that should be allowed and the decision points, but also the context is here specified, like the data that is used or the KPIs that should be involved and used. For this part, we used the Adonis business process management tool to capture exactly these processes. And then from these processes, we then use this information to align it to the technical aspects. This part is still ongoing research, but the idea is here that we now have all this information that we need in the processes, can map it to the AI services that we will use or want to use to help this decision. Of course, this must be mapped and configured to do this, but this is still the ongoing part. In this step, we use the RIT tool to describe the AI technology part, the components. And last but not least, what I want to say is kind of the results. So I'll now talk to you and explain to you how we get this user requirements. And now, what are the results? So we created specific scenarios for each project partner, and then we abstracted these support challenges. So groups of decisions that should be made. We identified resource mapping and solution configuration in the manufacturing production lines that the use case partners have. And then we have a selection. So this resource mapping and solution configuration provides maybe different possible solutions to the problem. And then we have a pre-selection done by the AI system, which takes the solutions and weighs it based on the parameters, and then provides it to a human. The human is here a central and important factor. And then it is executed, information is gathered that we can refine it. This is what I want to say about the requirements acquiring procedure. And I want to give to my colleague, Sylvia, who will talk about AI decision making.
Thank you, Christian. Within this webinar, I would like to take the opportunity and introduce you the initial research plan, as well as research directions in the domain of AI-supported decision-making. Please, Christian. In our research timeline, we can distinguish three main pillars: conceptual phase, examination phase, as well as the summary. Within conceptual phase, we plan to define research directions and specifications. We would like to also focus on given use cases from our industrial partners, which are crucial for the project's objectives. This includes, of course, multiple workshop sessions, on-site visits, as well as detailed discussions to understand the initial partner's needs. The examination phase, therefore, has the goal to collect all required knowledge and the data, and later on implement the AI into the current traditional decision-making processes and consequently improve them. Finally, we would like to summarize our results and the whole work from the project, ideally in the form of publications, workshops, and in-depth discussions with our research partners as well, to learn something out of this project. The next slide is presenting our research directions. The research concept starts for us from the different agents, which can be identified in a manufacturing environment. Such an agent can be a machine, a set of machines, a cobot, or even a human. All these agents have ideally their own contribution to the final decision, which is made by the decision maker. This person, of course, has certain objectives and the input information from different agents to further take the decision. In this framework, we see potential to implement AI on different levels here. We are asking ourselves how we can accelerate the decision-making by using AI methodologies, or how can we create a hybrid solutions with already existing classical rule-based decision support systems. We also focus on the optimization of the production planning and scheduling, Optimization always is performed with respect to specific metric. For instance, in the scheduling domain, this can be the make span, resource utilization, or job tardiness, among others. Different metrics can also be combined in a Pareto optimization, which brings optimization to another level. Taking into account reinforcement learning, these metrics are manifested in the reward function, which is crucial for the learning behavior of the system. We want to investigate which representations are the most suitable for tackling scheduling optimization problems with reinforcement learning approach. That brings me to the end of my presentation, and of course, thank you for your attention. Now I will hand over to my colleague Gustavo, who will present you the research directions regarding the multi-agent system.
Thank you. Thank you, Sylvia. So I'd like to start making a short contextualization asking, how can multi-agent systems contribute to the democratization of decision-making in the industry? How can multi-agents be an important technology for the promotion of fairness throughout the manufacturing industry? Include the participation of all stakeholders involved in the decision-making process through agentification. Multi-agent systems enable decentralization of decision-making processes, reducing the reliance on centralized authorities that do not always have the true overview of the process due to the lack of proper participation of important parties in the decision-making. Allowing multiple agents that represent those stakeholders to interact and negotiate autonomously promotes a more equitable distribution of power and control. The participation of each human, individual, and asset substantially involved in the manufacturing activities must be taken into consideration, and their participation expressed in a digital form. From this, their roles and objectives can be quantified and properly addressed. Digitizing the interactions between the stakeholders means making it possible to manage the distribution of loads, costs, and factors associated with their dynamics and goals regarding these metrics desired in the system. Agents are communicative and can interact with each other to achieve common goals. MAS considers how the relational dynamics between entities impact issues such as work efficiency and improve system resilience when disturbances occur, providing a helpful environment of communication for balancing parameters in manufacturing settings. Also, MAS enables the pooling of knowledge and resources from various agents, allowing for collective intelligence. AI algorithms can be embedded in agents and help to achieve certain goals more effectively. Assist decision-making through a recommendation system in a timely manner with the human perspective. By fostering collaboration, decentralization, and transparency, multi-agent systems can empower stakeholders to participate more actively in the decision-making process. They perceive their environment and respond in a timely fashion to changes that occur in the environment, also taking the initiative when it considers it appropriate. In the next slide, the methodology for multi-agent systems application. Technically speaking, we have to first identify the stakeholders. It can be a robot, a person that is involved in the execution of a task, orders that enter the production line, schedule optimization, cost savings, quality checks, improvements are some of the common goals. Work balance distribution, taking attention to objectively aim to a fair approach with human well-being in mind. Production resilience is usually well achieved with MAS mechanisms that provide manufacturing adaptation when unexpected changes happen. UML is one of the tools used for modeling. It is useful for defining how the agents interact with each other and what actions they take among themselves. For dynamic modeling, Petri nets are quite useful for representing the multi-agent system behavior in a graphic visual form. Each agent can be independently modeled as modular component, what proves to be useful for scaling purposes. Then we proceed to the actual development of the multi-agent system after modeling and further debugging. And code validation, paying attention to the requirements raised in the beginning. In the end, we deploy a developed system in real use cases and validate it after meeting the functional requirements. In the next slide, the multi-agent system research approach. As discussed previously, if you can go to the next slide, please. Thank you very much. The multi-agent systems is a technology enabler capable of promoting distributed intelligence to the manufacturing industry and assisting in the creation of mechanisms that promote the democratization of decision-making. So we ask, which approaches involving mass can better fit FAIRWork's needs and provide a feasible and practical implementation in an industrial setting? HMS, bio, multi-agents can be approached under different architectures. What aspect can each provide as an advantage for promoting fairness in the manufacturing industry, competition and comparison characteristics? How to push mass technology beyond lab scenarios more often? How can you contribute to the maturation and consolidation of multi-agents in the industry? And as research directions, we point out, what are the necessary interactions to achieve FAIRWork balance use multi-agent systems consider the human in the loop? In other words, what are the necessary precautions to be taken while modeling multi-agent systems in order to ensure proper inclusion of the human entity's participation? How to combine artificial intelligence with multi-agent systems? How to distribute and balance artificial intelligence algorithms in mass? How different AI techniques can impact mass modeling? We approach research following these guidelines. Thank you for your attention.
Thank you, Gustav. Now, Lucas will present us some insights regarding human factors.
Thank you, Herwig. Welcome now to the part on another research direction about the digital human factors technologies. On the next slide, basically, you can see that we now put a focus on the human actors and the human factors of the acting, in particular, decision-making human operator. In particular, there is a focus on the impact of stress, such as, for example, high time pressure or sleep deprivation on the decision maker. And as a consequence, the impact of the human's potentially detrimental selection strategy on the decision-making process. In the next slide, we see outlined key points of studies about human decision-making that have demonstrated that stress has a negative effect on risk-taking. So, since all decisions involve some element of risk, stress has a critical impact on decision quality. However, decisions are found to improve with stress up to an optimal threshold, beyond which a decrease in performance is observed. The naturalistic decision-making research shows that in situations with higher time pressure or higher stakes or increased ambiguities, experts may use a kind of intuitive decision-making rather than a better way of structured approaches. They may in this way arrive at the course of action without weighing any alternatives and end up with a tunnel attention by overlooking. Furthermore, the information overload affects the tasking itself, which affects decision-making in a way that the human's decision-making becomes inhibited because the human brain can only a limited amount of information. Finally, decision fatigue is when a sizable amount of decision-making leads to a decline in decision-making skills. In the next slide, we recognize components of the research plan that foresees now the investigation of digital human factors technologies. This means that we mount non-obtrusive variables on the operator. We selected sensor technologies, as you can see, such as a biosensor shirt on top, eye-tracking glasses, or biosensor smartwatch or smart band. And please note that there will be in addition sensors capturing the state of the environment as well, such as the quality of air around, the temperature, the humidity, and so on. In practice, everything that might stress the actor or promote well-being should be measured. These should implicitly capture information about the human factors during work, during the task execution. Now we intend to map these raw and fused feature data to various psychological constructs that would inform about the cognitive, the affective, and also the motivational state. For example, such as cognitive emotional stress, mental or decision fatigue, or sustained attention, also called or known as concentration. This intelligent mapping will be applied also in terms of some kind of machine learning functionality. That means AI-based, but very close to the specific interpretation of digital sensors and with the understanding of the psychological constructs. It is important to note that we intend to apply instruments of explainable AI to render the AI-based decisions as transparent as possible and to make them trustworthy as well. In the next slide, we emphasize the role of the Human Factors Lab of UNEOM Research, where we will be able to explore the various stress conditions using various platforms, could be, for example, virtual reality, cognitive emotional stressors of a decision maker, but also physically strained workers kind of stressors. We'll also perform studies with participants in the lab in order to optimize the parameters of the digital human factors components. We have several technologies at hand, such as a research-oriented flexible dashboard that you can see on the bottom picture, that enables to follow the continuous stream of raw data and also computed metadata of interest that are computed in real time. And in the next slide, this presents one principal research direction, that is to develop a framework of a human digital twin. And this framework would be based on the concept of so-called personas, representative profiles of person as a part of a specific target group that are often and typically used in human factors, for example, in requirement engineering. We intend here and are very glad to closely cooperate with the expertise on human factors of the project partner RWTH Aachen. Basically, the feature space of individual decision makers or workers could be clustered into meaningful sectors, such as for older workers or young workers that may have a lower stress sensitivity, and these classes would be related to a kind of reasoning structure. For example, decision trees, which are very good for explainable AI, and that can provide the targeted information for decision support for the further processing and insight. The research on the digital human factors technology is ongoing, and of course, we will be happy to inform you about the progress in the future. So I would hand over back to Herwig to progress.
Thank you, Lukas. So now I will present you the initial outline of the FAIRWorks architecture. On the next slide, you see this complex architecture. At the first glance, it looks complex, but we will see after my walkthrough through the architecture, we need all these components. On the next slide, I start with my walkthrough. What you really need is a real world use case, and we choose the production domain. There, it's important that you have this use case, and when you have this use case, you should ask yourself, what are the objectives there? What are the global objectives? What are the local objectives? Example of objectives are all products should have nearly no defects. You want to have very energy efficient processes, steps. You want to deliver most of the transport for the logistic in time. And as we heard from Lukas, you want to reduce the stress of the workers. To reach this, you need data, and you need an infrastructure to collect it. And in a factory, there could be some programs already available where you get data. Then you have maybe data services, which collects data from databases or other information structures. And then what we heard already from Lukas, you need biosensors to measure, to get the measurement from humans, but you need also to measure the environment, like air quality, etc. And last not but least, you can also get data from external marketplaces. And this data will be collected and then streamed to the knowledge base. The knowledge base you see on the next slide. The purpose of the knowledge base are twofold. First of all, it helps you to collect and stores and structure the data. Maybe you have to merge them and you can play with them. And you should also provide an interface for others to access this raw data. And the second purpose is that you store and collect knowledge. And the knowledge can be generated in two ways. In one way, you have the enrichment services. And another way is that you store also knowledge from different processes which were produced by humans. It is important to increase the knowledge over time. And this knowledge can be also used furthermore for another and new enrichment services, or it can be also used for humans to learn for it. On the next slide, I go to the configurator. The configurator is also a very important component. It is connected to various model environments, and it helps us to support the configuration of, for example, dashboards models. It helps us to define decision process models. It helps us also to configure the enrichment services, and it helps us also to configure a multi-agent system. This is important. And then the next slide, I went further to the enrichment services. Is one of the heart of the FAIRWork project. The main role of these components are to develop the intelligent services. We will develop different type of services. One group is based on purely machine-driven approaches. Others are using already explainable traditional AI algorithms. We call it symbolic AI. And the third group of models or services can use this multi-agent approach. It is important. All these models contributes to the decision-making process. And the result of all these individual services goes back to the knowledge base. When we go then to the final two components, orchestrator and user interface, orchestrator has a special role in this project. We deal with complex decision-making. So that means it's not enough to make just one service to make a decision. We have to build workflows out of it, so-called decision processes. And the coordinator, the orchestrator is here the key things to decide and coordinate all these services together. And finally, the human is part of our system. So we need the user interface and present the output of the decision-making process to the user. We will support different type of interfaces for mobile phones, for handhelds, for laptops, for TVs, using also more advanced like Google Glasses. It helps us to evaluate the output. Maybe you have different type of output of the services, and you can see this in this user interface. This is finally the walkthrough. And when you go to the next slide, I just want to make it clear, the initial architecture of FAIRWork is focused on complex decisions. So we need adequate number of building blocks. This is also a major difference to other related activities, which just focus more on data. We focus on complex decision-making. So FAIRWork supports you and generate new ways of decision-making. Decisions are made, in our case, decentralized. It's for humans. It should be transparent and fair. And in this sense, we built a democratic decision-making system. Thank you for the attention. Now, if you have any question, please let us know. So if there are no questions, we can go to the last slide. Here you have the contacts detail from us. We want to engage you, and we want to hope that you are getting in contact with us, and we want to stay in touch with you and cooperate for scientific paper, for research exchange. It is really a need, and we are really interested in your type of problems to discuss these topics from FAIRWorks in different application use cases. So keep in touch with us and contact. Here you have the contact details. Thank you very much for your attention.
Thank you, but before you leave, may I ask if I can make a screenshot, so kind of a group picture of everyone, so that you can please activate your camera so that I can make a short screenshot. So 1, 2, 3, cheese. Then thank you very much, and have a nice day and a nice weekend.
Thank you.
Thank you.